Morning guys, it's Una. This is the lesson plan for this week and next week, which will bring us to the end of term. So you won't be getting any more lesson plans from me until September. Okay, you'll be glad to hear that. We're going to follow the pack that was sent out in the post last week, the NALA Learner Pack. You already have it on email. And this week we're going to talk about lines, angles, triangles, and circles. Much of it is revision, so hopefully you remember some of it. Okay, so we'll kick off with lines and angles, and we'll read through page 24 and attempt the questions on page 25. And then I want to have a look at the types of angles and their descriptions on page 26. We look at the pictures below them to help you visualize what the angles look like. They generally use an arc or a circle to show you the size of the angle, except for a 90-degree angle or a right angle, which uses a square to denote it. Okay, so we flip over. Now, know your lines and angles. Okay, so parallel lines, first thing here. Okay, think train tracks. We've talked about this before. If two lines don't intersect, then the lines are said to be parallel. So we've got line AB and line CD, and it says AB is parallel to CD, and we write it as A parallel CD. That's the sign for parallel, and it shows you what parallel means, so it's kind of nice. Arrows are placed on the lines AB and CD to indicate that they are parallel. That's these arrows here. Okay, you'll see that in a lot of shapes where they have a symbol, two matching symbols on two lines. Tells you something about those lines. Now, perpendicular is the opposite of parallel. So this is like your T-junction, okay? The lines meet and they must meet at right angles. So a line meeting another line at a right angle or 90 degrees is said to be perpendicular to it. So here we have line AB again and line CD. There's AB, CD. And line AB is perpendicular to CD, and we write it as AB upside down T or perpendicular CD. Okay, AB is perpendicular to CD. Now, so next page, look at the following pairs of lines, describe them using the correct maths language. Okay, so you can imagine that's extended down there. So I want you to tell me what those lines are. They are something to each other. Okay, and remember the maths language that we've just used on the previous page. Okay, and same with this one. These lines are something to each other. So I don't want to hear that they're straight. I want to hear that they're either perpendicular or parallel. You tell me which. Okay, and then you go on to these two sets of lines and you've put a circle around the word that describes them. So are they perpendicular, parallel, or neither? Okay, so you tell me that. Now, moving on to angles. Angles are measured in degrees, and as the angle increases, the name of the angle changes. Now, you'll be familiar with the right angle, an angle that is exactly 90 degrees. And we'll go down and look at the picture here. Here we are. Here's our right angle, okay? Here's our square denoting that it's 90 degrees or a right angle. And what's happened there is if you imagine this arm originally started off down here with this one, okay? And it just rotated through a circle as far as here, which is 90 degrees. That's a right angle, okay? That's the one you know. Okay, now if we go back up, an acute angle, this one here, is an angle that's less than 90 degrees. Okay, so if we come back down here and imagine the arm here originally started out here, okay, and it decided to move through a circle up, but it didn't go quite as far as 90 degrees, okay? 90 degrees would be about here. This line didn't go that far. That creates an acute angle, okay? You can see the arc here. It's an acute angle. And you'll hear people talking about a very sharp bend or a very acute bend. Okay, so you can imagine if you're driving along here and you have to make this turn, that's quite a sharp turn. Okay, so an acute angle is a sharp angle less than 90 degrees. It's got to be less than 90 degrees. Okay. The next one is an obtuse angle. Okay, now in this case, if you imagine this arm started off on top of this one here and it started to turn through the circle again, went through all the acute angles, got as far as 90 degrees, which would be about here, and said, I'm going to keep going. And it did keep going and ended up here. This is an obtuse angle. Okay. All these definitions are given above as well. So an obtuse angle is greater than 90 degrees, less than 180 degrees. And 180 degrees is this angle here, also known as a straight angle, because this is, say, the center of our circle. So this is one arm, and then this arm would have started out on top of this one over here, but rotated all the way through the acute angles up to a 90-degree angle, kept on coming through the obtuse angles, and went as far as 180 degrees, the semicircle, okay, and you can see it made a straight line with the original arm. Okay, and on this one, this is our arm here. If this arm, this one here, started off on top of this one here and rotated all the way through the acute angles, got up to 90 degrees, decided I'm going to keep on going, went through all the obtuse angles, ended up straight there at 180 degrees, but then kept on going. A reflex angle is greater than 180 degrees. That's what that one is. And on this one, the arm has just done a full rotation all the way around the circle, okay, and ended up back where it started to give you 360 degrees, okay? So acute angle, less than 90. Right angle, exactly 90. Obtuse angle, greater than 90, but less than 180. Straight angle's got to be exactly 180 degrees. Reflex angle is greater than 180 degrees, and the full rotation is 360. Okay, so that's what that's about. Now, moving on to triangles. Okay, and in our notes, it just says, done all that. It tells us, take note of the right angle triangle on page 27 and the word hypotenuse. I'll go over this in the video. Okay, that's what we're doing. But it's important to know this word. Okay, so this triangle is a right angled triangle. You can see that there. There's our square to denote 90 degrees. This side, okay, is beside the right angle, as is this side, it's beside the right angle. This side over here, the long slanty one, the longest one, is opposite the right angle and is known as the hypotenuse. Okay, that's an important word to remember. You will see a lot of that as you continue to study geometry, and you will come across it when it comes to Pythagoras' theorem. Okay, very old theorem, very important theorem in maths. Okay, so this is your hypotenuse, the slanty line opposite the right angle. Okay, now it asks you to have a look around the room and find lots of different angles and triangles. Don't do that. It's a little bit difficult to do on your own, okay? And it also asks you to draw a variety of shapes using criteria that I'll give you. Again, it's a little bit difficult to do on your own over video, okay? So I'm not going to do that one. But I do want you to do this one. Draw a right angle triangle according to the measurements that I'll give you. Label the side opposite the right angle using its correct name. We've just done that, so you should remember that. And the measurements that I'm going to give you are here, okay? The measurements are the triangle, the height is 5 centimeters, the base is 6 centimeters. So I want you to draw a triangle, a right angle triangle with base 6 centimeters, height 5, and make sure you put in your hypotenuse and label it. Okay? Don't do page 28. That's about bisecting an angle, and it's difficult to do on your own for the first time. You also need a compass for it. And we'll read through pages 29 and 30. This is about triangles. I just want you to let me know anything you don't understand, and then we're going to skip page 31 as well before we get on to circles. So I'll just flick back here. We are not going to do page 28. Like I said, that's hard to do on your own for the first time. Finding the area of a triangle we are going to do. So we can find the area of a triangle by using this formula. Half the base multiplied by the perpendicular height. Okay, so here's our perpendicular coming in, telling us that's what that means. And we're going to use that formula to work out the area of the following triangles. Okay, so this one is easy. The base, 5 meters. We need half of that multiplied by the perpendicular height. Okay, you can work that out. Use a calculator. Again, here's our perpendicular line, our T-junction if you like. Here's our base, and here's our perpendicular height. So half the base by the perpendicular height. Okay, now here's our perpendicular height. If you extend this angle, or line I should say, across, you'll get the perpendicular height of the triangle. Okay, it's not a right angle triangle, so it's not as straightforward as that one, but our perpendicular height is 2 meters. You can flip the triangle over. The height of it won't change, okay, but you can now call that your base. Otherwise you don't know what your base is. If you're trying to figure this out, you don't know what it is, or this one. Okay, so use this as your base. Okay, so it's half the base by the perpendicular height. Okay, and then we're talking about furniture. Okay, sorry, a little break there, guys. Okay, triangles and furniture. In everyday life, we often see triangular tables or shelving units placed in the corner of rooms. So if you look at the floor plan here, it shows you a triangular shaped corner unit down here. Okay, and you have measurements for it. It shows the base here. Okay, depends on how you look at your triangle as to what you call your base. So what they do here for the solution is they actually flip it around. So that's what was our base in the picture, but they flip it around to put the base, the right angle on the bottom here. Okay, using our formula again, half the base by the perpendicular height. Here's a base, 0.5, and the perpendicular height, you can see easily, is 1 meter. Okay, so it's going to be 0.5 by 1 meter, or they've written it as 1 meter by 0.5 here. Either way, your answer is 0.5 meters squared. Okay, so you'll need 0.5 meters squared of floor space to fit the corner unit. Go over that. Let me know if there's anything you don't understand. We are not going to do this page, and I'm going to record a separate video for you for the circles, because I probably won't have time to get it all in on this one.